All right, so look up, look up, look up. Let's see how we can differentiate y equal to let's see how we can differentiate y equal to 1 all over root x using first principle for the college guys specifically. Now, what's your first task here? Your first task is that if you look at the question here, it is given to you in terms of fraction. Your first task now is that you want to convert it from fraction to index form. And how do you do that? I know fully well that if I have 1 all over a, this becomes what there? A to the power what there? Minus 1. That's your first task. In essence, this will be the same thing as saying y is equal to this in bracket root x to the power what there? Minus 1. Please. It is the minus 1 concept that eliminates the 1 over that makes it a what? Fraction. That's your first task. First step. What's second step? Second step is that recalling from the concept of sorts, that if I have root A is same as what? That's a to the power what there? 1 over 2. In essence, this man here will be equal to y equal to, this gives you x power what there? 1 over 2. This one here is same thing as root x, all into what there? Minus 1. Okay? What next? Next up, again, recalling from the laws of indices. If I have a to power m multiplied by n, this will give you what there? A to power what there? Mn. In essence, I'm saying that these two can multiply. So that means y is equal to what there? X to power what there? 1 over 2 times minus 1 gives you what there? Minus 1 over. All right. At this juncture, we can now start the solving. This one here was to express it in the form, index form first. Now we can start the solving. Let's now solve this. In solving this, our task is simple. What is the idea behind first principle? To y, add what there? Change in y. To x, add what there? Change in x. Please listen so that you don't mix it up. Listen. So this becomes y. To y, I will add change in y. This is equal to, I have this one here. To x, you add what there? Change in x. Raise it to this power. Minus 1 over 2. All right. So you have this. Of course, if this was x squared, we know it to be what there? X plus change in x, or what there? Squared. Okay, let's proceed, please. From here, this will give you y plus change in y. It's equal to, let's expand this stuff. That's where the problem comes in. I mean, if this was x plus change in x squared, we know what to do. If it was cube, Pascal's triangle. Now it's not the power 1 over minus 1 over 2. Not even 1 over 2, minus 1 over 2 for that matter. How do I expand this? At this juncture, listen. At this juncture, again, listen. How do you expand this? What do you do? So look up this. Look up. Here's how to listen. Let me give you a formula. If I have I'll clean this. Well, look, just watch this. If I have a plus b to power n, where n is a negative or rational. Let me bring it down for space sake. Please. For space sake. If I have this a plus b to power n, how do you expand this? That becomes the question. How do you expand this? I know I have something on this, but then look up. The formula is this. Just watch this. Just catch this. The formula is this. The first term takes the power. That becomes a to the power what there? N. That's the first thing there. First term takes power. That's all. Plus, for second term, look up please. For second term, the power comes down here. What's the power here? So it becomes n into what there? A, subtract 1 from here, becomes what there? N minus 1. Bring in second term, B. Please hang on. Just watch this. Plus my next term, if you observe something, look up. There's a pattern here. What's the pattern? I have this. For my next case, what do I observe? Observe that whatever thing you had as a power came down here. And that was this. What again? Observe that the power of A was reduced by 1, n minus 1. What again? In this case, the power of B is 0 in actual sense. It increased from 0 to what there? 1. In the next term, what will be the power of B? 2. So you have B squared. Okay. Now we said this part came down, we had n. Bring this part down here. What do you have there? N into what there? N minus 1. Okay. What happened to A here? I reduced the power by 1, n minus 1. So if you have A here, this is n minus 1. Reduce 1 from here. That's n minus 1. Remove 1, minus 1. That becomes n what there? Becomes n minus 2. What will be the power of B here? B squared. All over 2 factorial. Now listen. This one here was all over 0 factorial. 0 factorial is 1. This one here was all over 1 factorial. 1 factorial is 1. I did not bother. This one here is 2 factorial. It has a value. So I bothered. Plus, what will be the next term there? Can you choose pattern? What will be the next term there? N. Hold on. N into what? No. Hold on. I did not jump from n. Look up. I did not discard this n minus 1. Hold on. When I was bringing n minus 1 down, observe this one was repeated first before I brought this down. So repeat this ones first before you bring it down. What do you have there? N into what there? N minus 1 into what there? Into n minus 2 into what there? A to power into what there? All over. Good. That's simple. Plus, give me the next step. What will it be? N into n minus 1 into n minus 2 into n minus 3 into a to power what there? N minus 4 into all over. Final term, please. Final term. One last one. What do you have there? N into into this was the n minus 5. A to power what there? Into all over. You know hard as you think. But if you know hard, it's a pattern. Understand it. It's not hard, it's a pattern. But the good news here is that we don't even need this one and this one. We can just stop here. But I was trying to teach you how you get it. Right? These are easy. Right? So we just need these ones here. I will use this to expand this. So please look up. I'm moving this one here. I don't actually need this. Don't worry. I will just show you how it's done. All right. So look up. Compare this to this. In this case, what I have here is x plus. This is the only way to expand this. Only way. This is x plus change in x, all to power what there? Minus 1 over 2. Please, from here, compare these two, please. What's the value of a? X. So we can say a is equal to x. What's the value of b? What's n here? N is equal to minus 1 over 2. In essence, to expand this one here, just put, whenever I see a, put x. Whenever I see n, put this. And that's how you expand it. That's all. So let's take this one by one. This will be equal to expanding this. What's the first term there? A. What's a there? X to power n. What's the value of n there? Minus 1 over 2. I have gotten my first step. That's all. That's all. Next up, plus. So I have plus. I have what here? N. What's the value of n? That becomes minus 1 over 2. That's n into a. What's a? A is x. So into x to power what there? N minus 1. What's n there? Minus 1 over 2 minus 1. Okay. N minus. Then b. What's b there? This dot change in x. That's all. Plus, let's get the next term here. What do you have here? N. What's n there? Minus 1 over 2. That's n into n minus 1. That becomes minus 1 over 2 minus 1. That's n minus 1 into a. What's a there? A is x. So into a dot x. A to power what there? N minus 2. What's n there? Minus 1 over 2 minus 2. That's n minus what? 2. What's next in there? B squared. What's b? Change in x or what there? Squared. So I have this all over what there? 2 factorial. Well, there's a third term, but we can stop here anyways. We can stop here, don't worry. Let's stop here. So this is it. I will tell you. Now, okay, let me just look up. Look up. Let me tell you. This is how you know where to stop. Remember, listen. How do you know where to stop? Remember that after, in first principle, after expanding this, what do you do next? Move y, Abby. At the end, what do you do at the very end? Divide by what there? Change in x. Before you put x as what there? How do I know when to stop? Listen, stop where you have change in x there. On a normal case, this is where I should stop. Because I have change in x squared here. If I divide here, what will divide by change in x? If I divide it by change in x, divide change in x squared by change in x, what happens here? You will still have change in x, which will become what there? 0, useless. So this is why we need to stop, where you have change in x. But just one for the road, so I added this. If you have enough time, you can add this one and the other ones too. All right? If you have enough time. Look up, please. Look up. Back to base. Look up. Let me expand this. Look up. Let me expand this. Now, my next start normally would have been move y over here. But you only move y over here when you have simplified. Right? This thing has a value, simplified. This thing has a value, simplified. These things have a value, simplified. 2 factorial has a value, simplify first. So let's simplify. If I simplify, this becomes y plus change in y, it's equal to, this gives you x to power what there? Minus 1 over 2. Let's simplify this one here. What do I have there? This is plus, what do I have here? Okay, hold on. Let me help out. Look up, oh. This is plus minus 1 over 2. Plus minus gives you what there? It becomes minus 1 over 2. Those guys, I don't know if you can see what I'm doing. Then x into minus 1 over 2 minus 2. Minus 1, what do you have there? Huh? So, when I was doing this, before you have calculator, listen. Before you start using calculator, this is a shortcut to use. Literally. If I have case like this, look up. If I have case like this where you have a fraction and a whole number, using calculator will slow you down. What's the fast step? Your fast step is simple. This works if I'm having a fraction and a whole number. All I have to do is multiply these two. So 2 times 1 is 2. Minus 1 minus 2 is what there? Minus 3 all over 2. That's your answer. Minus 3 over 2. Listen again. Listen again. When you have something like this, minus 1 over 2 minus 1, something like this, whole number here, before you pick up calculator, I've given you your answer. How do I get my answer? Simple. Use denominator to multiply this number here, the whole number. This becomes 2 times minus 1 gives you what there? Minus 2. Minus 1 minus 2 gives you what there? Minus 3. That's a numerator all over this. That's all. So if I have minus 1 over 2, let's say minus 3 for instance, what's your answer there? 2 times 3 is what there? 6. Minus 1 minus 6 gives you what there? Minus 7 all over what there? 2. Before you punch, I don't give you answer. That's all. All right, here, change in x. Now, hang on again. Hang on. Please watch. I want to do step by step. This becomes, let me use plus here. Keeping my plus. In bracket, I have what there? Minus 1 over 2 into, what do you have here? 2 times 1, 2. Minus 1 minus 2 minus 3. This will give you minus 3 over 2. Punch if you want to. Come to this. This gives you x. Hold on. This gives you x. To solve this one again, 2 times 2, 4. Minus 1 minus 4, minus 5 over 2. Simple. Minus 5 over 2 dot change in x squared. All over what there? What's 2 factorial? 2 factorial is 2 times 1. That's what there? 2. All right. All right. I don't know. Should I bring it that way? See, do you know that if I write this as saying this is equals this times 1 over 2, this, look up please. If I write this is this all over 2. But I'm saying if I write this and I don't put all over 2, I just say times 1 over 2 is the same thing. Are you aware? Yes. So can we do it that way? Yes. Or do we leave it this way? All right, leave it this way. Let's see what we can get here. I am not done. I still have to simplify this. All right. So that becomes y plus change in y is equal to x to the power minus 1 all over 2 minus 1 over 2 x to the power minus 3 over 2 change in x. Look at this please. This is plus. What do I have here? Minus 1 times minus 3 gives you what there? Plus 3. Minus 1 times minus 3 plus 3 all over 2 times 2, 4. This into x to the power what there? Minus 5 over 2 dot change in x to the power what there? 2 all over 2. All right. Please, these two are different, so please don't combine them. That's why I actually wanted to shift them, but no problems. I want to clean the first line, please. Just the first line. Yeah? Please, anybody see here? Let's do this. I have here as y plus change in y, it's equal to x to the power minus 1 over 2 here minus this one here minus 1 over 2 x to the power minus 3 over 2 times this times change in x. Please, how do you simplify this? What do you do? How do you simplify this? What do you do? So look up. If I have a fraction a over b being divided by another term, say c. If I have a fraction of a over b being divided by another term, say c. How do you simplify this? This thing here, hang on. This thing here is the same thing as saying a over b divided by C. And in solving division like this, we know that this is equal to what there? A over B times 1 over C. And that's equal to A times 1, A all over B times C, BC. So here's the summary of the whole matter. If I have a fraction being divided by a term, this will be equal to keep the numerator constant A, multiply this to B times C, BC. That's all. Again, keep the upper numerator A there, multiply these two terms, B times C, BC. Why am I saying that? Because for this term here, what you have here is actually 3 over 4 divided by what there? 2. And how do you solve this? This becomes what there? 3 over 4 times 1 over 2. And that gives you what there? 3 over 8. Keep this one constant, 3, multiply this 2. So you have 3 over 8. That's how I simplify this. So plus 3 over 8. This, now repeat this term here. That's x to the power minus 5 over 2 dot change in x squared. You have this. All right, I think we are done simplifying. Now look up. Listen. First principle, my first task here was to write this in index form, which I did. Task 2, to y add change in y, to x add change in x, which I also did, and I expanded using all the method I show you. We arrived here. What's the next step? No, that's the next step. When you expand your bracket, what's the next step? Move y over there. So move y over here. What do you have here? Change in y, it's equal to x to the power minus 1 over 2 minus 1 over 2 x to the power what there? Minus 3 over 2 change in x plus 3 over 8 into x to the power minus 5 over 2 change in x squared. Y comes over, it becomes what there? Minus y. But what y? But y is equal to what? Minus 1 over 2. We have this. Okay, let's put that value there. If I put that value there, this substituting, if I substitute, I have change in y, it's equal to, this gives you x to the power minus 1 all over 2. This is looking like, this is a power, please. It's not looking like, it's a power minus 1 all over 2 x to the power minus 3 over 2 change in x plus this 3 over 8 x to the power minus 5 over 2 change in x squared minus, what's the value of y? In our first example, we said put y in bracket, which we did. In this case, do I put y in bracket? Why? When I did the first one, then we said put y in bracket, which I did. In this case, do I have to put y in bracket? Yes or no? You put y in brackets when it's what there? Several terms. In that first one, you had y equal to plenty numbers. In a case where y is equal to just a single term, look at this, y is just one term. You don't have to put it in brackets, the same thing. So in essence, this becomes what there? X power what there? Minus 1 over 2. So you have this. Please check, can any term cancel out? Yes. All right, please check, can any term cancel out? Yeah? So I have change in y is equal to, look at this. This is x to the power minus 1 over 2. This is minus x power. So that means this can cancel this. A proof that we are on the right track. We'll cancel out. I am now left with what there? Minus 1 over 2 x to the power minus 3 over 2 change in x plus 3 over 8 x to the power minus 5 over 2 change in x squared. That's all. All right. Please, after subtracting y, what's my next step? Good. Divide by change in x. Divide by change in x. I want to take up the first two lines, please. Um, all right, divide by change in x. What do you have there? This first term here, change in y divided by change in x, it's equal to this term here, minus 1 over 2 x to the power minus 3 over 2 dot this one here, change in x. We said divide by change in x. So this term here, which is this one here, divide by change in x, plus what I have here, 3 over 8 into x to the power minus 5 over 2. This one here, change in x squared. This divided by change in x. You have this. Please, I want to clean. Back to business, please. All right, from here, from here I have change in y over change in x. It's equal to, from here, it can be seen that this will cancel this. This is all over 1. So I'm left with what there? Minus 1 over 2 x to the power minus 3 over 2. This is gone. This is all over 1, so it's gone. Plus, what do you have here? This becomes 3 over 8. This into what there? X to the power minus 5 over 2. This cancels this. I'm left with what there? Change in x. What's your final step? Take the limits. Take the limits of change in x to be equal to what there? 0. That means wherever I see change in x, put 0. So what do you have here? Change in y over change in x is equal to minus 1 over 2 x to the power minus 3 over 2. There's no change in x here. Proceeding, plus 3 over 8 into x to the power what there? Minus 5 over 2. This becomes what there? 0. And this is equal to, write this one out. I have what there? Minus 1 over 2 x to the power what there? Minus 3 over 2 plus this times 0 gives you what there? 0. Final answer, what do I have there? Minus 1 all over 2. This one here. X to the power what there? Minus 3 over 2. That was the answer you got. So it's correct. All right. Yes. When you use general was this now, right? It's correct. Well, you can choose to simplify if you want to. You can start putting back the square root, but you have this answer. So yes, it's correct. So basically, this is the answer to the question. Is it difficult? No. What's the problem? Lengthy. How many marks is this question from last year? How many? This whole stuff, this stuff is 7.5 marks. Yes, only 7.5 marks. That's it. All right, let's proceed.